Hey everybody, welcome back for another video in my series so that you can learn VEXcode VR. Today we're going to talk a little bit about autonomy and what it means for a robot and how we can build some blocks into VEXcode VR that allow the robots to make some decisions more on their own than waiting for us to tell them exactly what to do. Okay, this idea of autonomy is letting the robot itself make decisions based on its own senses, based on its own systems. We all crave autonomy. We all want to be able to do our own thing. But it definitely takes a little more effort in order to make autonomy happen. It's really easy to follow someone's instructions. It's a little bit more difficult and takes a little bit more energy on your part to understand how to not just listen and listen to what someone is telling you to do, but how to actually make decisions yourself. But in the end, putting in that extra effort means you are going to be more flexible and adaptable to whatever situations you are encountering as a person or whatever a robot is encountering as a robot. So in order to do this, I want you to think about some of the commands we've been giving the robot to do. So we've been telling it to drive forward 200 millimeters. But there's a lot going behind the scenes in order to actually get this to do it. What we're really telling the robot to do is start driving, check to see how far you've driven, and if you've driven 200 millimeters, stop. Otherwise, keep driving, keep going forward. And so this structure of saying we're going to keep doing something until a condition is met is key to being able to build autonomy into our VEX robotics programs. So let's take a look at this situation. We can use a whole bunch of different sensors, for example. Let's say we want to drive forward until we are 500 millimeters from the wall of, it could be on the floor if we were building a physical robot, or from the wall in VEXcode VR. The reason this is different is that depending on where you are when this part of the program runs, you might have to run a different amount of time or a different amount of distance. So this just says, I don't know where I am, but drive until you, robot, according to your sensors, you are 500 millimeters from the wall. And the virtual robot does have a sensor like that built into it. In fact, there are a lot of really interesting sensors that are available in this robot. You have a timer, so you can ask the robot how long has something been going on. You can reset that time, kind of like just a stopwatch. You can simply ask, are you moving or not? You can ask it in what direction on the field is the robot pointed. And there are two ways that VEXcode VR lets you use that information. One is thinking about a compass, and another is thinking about an angle of rotation from zero. There are bumpers on the robot. You can tell if it has bumped into something. It has a distance sensor. It acts a little bit like an ultrasonic sensor where it bounces ultrasonic sound off of whatever's in front of it, listens for the echo, and from the time that it takes for that sound to go there and back, it's able to figure out distance. So there's one of those built in. It also says, is there an object in front of us? So that's this distance found an object. So it'll tell you the distance from an object. It will tell you if it's found an object. It has an eye on it, which will tell you what color does it see. Does it see anything? Is it bright? Is it dark? And you also have the ability to tell the position of the robot and the angle of the robot that you may want to use. And so all of these things allow you to go back to these structures where you can drive until a condition is true. Drive forward until you are 500 millimeters from the wall. Drive forward until your Y position is negative 600 millimeters, for example, or drive forward until you have hit the wall. So let's take a look at all of these in VEXcode VR so we can get an idea of how to use these ourselves. All right, so here we are in VEXcode VR. Let's try implementing the task that we had right here. Drive forward until our robot is 500 millimeters from the wall. Now before we get to that, let's take a look at some of the options that are built into VEXcode VR so we can see the different sensor options. So if we look over here, we can see that we have a heading and the rotation of the robot. So the compass heading, the rotation from 0, positive or negative. We have the front eye, which is a visual sensor, which can detect is there an object in front of it, true or false, and what color is it. And there's another one of those sensors below the robot. We can also get the location of the robot, its XY coordinate. It might be useful to know that the center of the grid is the point 0, 0. Location angle, I haven't totally figured that one out. Need to look at the reference manual to understand. The bumper is a virtual bumper switch to know if it is in contact with a wall, either on the right side or the left side. And finally, this distance sensor, which is like an ultrasonic sensor in front of the robot and tells what is the distance from the robot to whatever's directly in front of it. So let's play around with this. So we're used to using these drive forward blocks, okay, but we're going to do something a little bit different. We're going to use this concept that I showed you before, that we're going to continuously do something until a condition is met. And so we're going to drive forward, make our robot do that, until our distance sensor reaches 500 millimeters. So I'm going to get a Boolean block here and drop it inside. These repeat blocks will continue doing things until the statement in green is false. I'm sorry, it will keep doing that until the statement is true. So we want to continue driving forward until the distance in millimeters that it senses in front of it is equal to 500. So let's give that a shot. Run the code. All right, so you can see that distance dropping, and once it gets, oh no, looks like I forgot to tell the robot to actually stop. It is likely that you will make the same mistake as me. So let's, I didn't tell the robot what to do once that was no longer true. So it's going to drive forward until the distance is 500, and then it's going to stop driving. One more time, let's check it out. Okay, again, that distance dropping, 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 and then once it drops below 500, it stops. Now, one thing to be aware of, sometimes it's not good to use the equal sign as the condition in something like this, because while the robot is looping around, it's possible that the number actually skips right over 500. And what I mean by that is you're driving forward, you look at the sensor, it says 450, you look again, it says 470, you look again, it says 490, you look again, it says 510. So you actually miss that exact point of 500 because of the robot looping over and over again. So one way to prevent that is, instead of using an equals block, we can use a less than or equal to, and just say, I want to do this until that distance sensor reading is below 500 millimeters. I'm also going to try to speed this up a little bit, make the robot go faster. So I'm going to set the drive velocity to 100, see if we can really get that thing to fly. So let's try again. Going, 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 a little faster, and it stops. Because it's going faster, it's not quite as accurate, so if you want it to be more accurate, you may want it to slow down. Okay, so that's this capability. Let's try something else. Let's try something maybe with the X or with a Y coordinate. So instead of this being our condition, let's make it so that it drives until the Y coordinate, and that's going to be its position X in millimeters, and let's say is greater than 0, maybe that. So position Y in millimeters is greater than 0. And so looking at that, that should mean that the robot should stop right around here. If this is the point 0, 0, this is a Y coordinate of 0, so it should stop there. Let's try it out. So the only thing that's changed is that condition. It goes, it goes, it goes, and it stops. And we can see here in the location now that the Y coordinate is 20. So again, it went a little bit past it, which is why it's a good idea to use the greater than symbol. Okay. I want to mention something about flexibility. So this is working on this particular map. If we flip this around to a different map, maybe the number grid, Okay, as you can see here, this program still works. So we still drive, and it doesn't really matter when it's over. It stops when it gets to the position of y equals 0. But if we look at a different playground, it's starting in a different place, but my code doesn't really care. So my code, regardless of where it is, I still want it to stop when it gets to y coordinate of 0. You can sort of see where it is right now, so different map. It is starting in a different position, but it still is going to have the same kind of behavior. That's what I mean by flexibility. It means it can do different things in different situations. You don't necessarily know how many times you want it to loop. You just want it to keep doing what it's doing until a condition is true. And if you want to use a different sensor, for example, we could swap this back out, and wondering about this, maybe using distance finding an object. So drive until it sees an object. I'm just going to take this directly and throw it in there, and let's see what it does. So I wonder if I can get it to stop when it sees this obstacle in front of it. Let's try it out. Okay, so I guess that's not working. I'm trying to see here. It doesn't seem to have an object in front of it, so I'm not sure why that one isn't quite working. Let's swap this back out and again see if I can do the same thing as what I had before using the distance sensor in front of it. So let's just say to stop when it senses something that the distance in front of it is less than 50. Let's try that out. All right, so driving forward, and you can see this distance is 57 millimeters, so it gets right up to that object and stops. And so again, there are lots of different ways that you can play with this. There are a whole bunch of different sensors you can play around with in here. I want you to experiment, think about different conditions for it to continue repeating. You might try this having it turn until a certain condition is true. There are lots of things that you can do with this. I want you to experiment and send me an example of what you put together using this new concept of waiting until a condition is true in order to move on and continue your program. Okay, good luck and have fun.